So today we're going to be looking at the median. So as you'll remember, the median is the median splits the set of data into two parts with an equal number of values in each part, the bottom and top half. So we're going to consider the median for ordered sets. We'll do ordered sets first, and then afterwards we will look at looking at the median for data sets which is a large data set of continuous data. So firstly, for ordered sets, if we have a set of n ordered values, the median is the halfway value between the first and nth value. So therefore, the median is worked out by taking the n values, add 1, and then divide by 2. So it's the n plus 1 divided by 2th value is the median. Now if you look at this, if we had an even number of values, you're going to add 1, you're then going to get an odd number divided by 2. So so sometimes the median is actually going to be between two values, and we'll see that as we go on. We're going to look at some examples. So let's look at an example to explore this a wee bit further. I'm just going to draw a line here. So we're going to consider a DIY store. So it opens 12 hours on Monday and 15 hours on Saturday. The number of customers that arrive each hour is that are served each hour are recorded on the Monday and the Saturday, and we record the data in a stem and leaf diagram. So if we have the Monday on this side, and remember that was for 12 hours. And then we have the Sunday on the other side. Not Sunday, it's Saturday. And that's 15 hours. And so remember, we have to have a key. So we'll write the numbers in. So we have 8, 6, 3, 1, 0, 0, a 2 here, and then a 2, 3, 4, 6, and then here we'll have 4, 3, 1, 1, 0, and a 3, and we'll have 5, 5, 6, 8, 9, 9, and here we've got a 1 and a 4, here we've got a 0, 1, 3, 7, 9. So then the key here, if you have 0, then the 2 and the 2 represents, so this would be 20 customers on Monday and 22 customers on Saturday. Now what this doesn't tell us is what hour, so we don't know at what hour there was So this part here would be the 20 customers on a Monday. This doesn't tell us which hour in the day those 20 customers came in. This one here be 41 on the Monday. It doesn't tell us which hour those 41 customers came in. So it's really important that when you're looking at this data, we don't know which hour, which value corresponds to which hour in the day. So we can use this to find the median of the customers served in each of these days. And we would need to find the position on the stem and leaf diagram. So let's think of for Saturday first. The number of values is 15 because there's a value for each hour in the day. And they're arranged in ascending order. So 22 was the quietest hour and 49 was the busiest hour. So we've already got all the data arranged in order here. So for the median, we'll take n plus 1 over 2, which is 15 add 1 over 2, which is going to give us the 8th value. So if we go through it, 1, 2, 3, 4, 5, 6, 7, 8 is this one here, so it's 38. So the median number is 38 for the Saturday. Now we can do the same for Monday. So this time, Monday, the n is 12 because there's 12 hours that the shop was open for. So again, we'll do n plus 1 over 2, which is going to be 12 plus 1 over 2. Now as we see here, we're going to have 13 divided by 2, which gives us the 6.5 value. So it's between the 6th and 7th. So let's find the 6th and 7th. So this time here, this is the first value. So 1, 2, 3, 4, 5, 6. So there's the 6th. So the 6th value is 28 and the 7th value is 30. So to find the halfway between these two, so the median number, what we'll do is we'll take the 28, add it to the 30, and then we divide by 2. And that gives us 29. Now, when the data appears on an ordered frequency table of individual values, we use the cumulative frequencies to investigate the positions of the values, knowing that the median is still n plus 1 divided by 2. So when in an ordered frequency table, n is equal to the total frequency, which is the sum of all the frequencies. Let's look at an example of this. So we've got 65 ungrouped readings of x. The cumulative frequencies and positions are shown in this following table. We want to find the median value of x. So x is, oops, dodgy table, frequency, the cumulative frequency, and the position. So when x is 40 11 times, and the cumulative position frequency is 11. So that's between the first to the 11th position. Then it's 41 23 times, and this takes us from, so if you think about the different positions, you've got from 0 to 11, then you've got from 0 up to the 23rd, from the 11th to the 23rd, so the cumulative frequency is 34. So that's from the 12th position to the 34th position. Then x is 42, and that frequency is 19 times. So the cumulative frequency is 53. So that takes us from the 35th position to the 53rd position. And then we've got 43, that's 8 times, 61, and then that's from the 54th to the 61st time, and finally 44, and that is 4 times, comes to 65, and that's from the 62nd to the 65th time. So the total frequency is all of these summed together, which is this, is 65. So n plus 1 over 2 is 65 plus 1 over 2, which is equal to 33. So the median is at the 33rd value. So let's look at our table. Where is the 33rd value? So it's going to be in here. So our median is 41. So the median value of x is going to be 41, because all the values between 12 and 34 are equal to 41. Now, sometimes we need to estimate the median. When we've got a large data set, of continuous data. The values are grouped and actual values cannot actually be seen. This means we cannot find the exact value of the median, but we can estimate it. The method used to estimate the median for this type of data is by reading the value from the cumulative frequency graph. We estimate the median to be the value whose cumulative frequency is equal to half the total frequency. So let's consider, now I've not got proper graph paper here, so this is going to be not a very accurate picture of what we're doing. So here we've got the cumulative frequency. Let's write frequency. And we're going to consider that this is going to be the masses of 300 museum artifacts. So we're going to have 50, 100, 150, 200, 250 and 300. And then we have 1, 2, 3, 4, 5, and this is the mass in kilograms. So trying to draw this as kind of accurately as I can. Let's say it goes. That's meant to be straight lines. So we look at the cumulative frequency, it's 300, so the halfway mark is going to be 150. So we use, for a cumulative frequency, with total frequency n equal to the sum of all the frequencies, the median is the n over 2 value. So this is our key point to remember, and note how it varies. How it's, you don't have n plus 1 with the cumulative frequency graph. It's just n over 2. So for this one, we've got 300 divided by 2 is 150. So it'll be here. So we'll take our line from here and then drop it down, and this here is our median. You'd be doing this on a proper graph paper so that you would get a, although it's still an estimate, it would be a good estimate. And for drawing these lines, use a ruler so that you get it as accurate as possible. In this example, it's kind of coming out about 2.6 kilograms. So when you're looking at, so we need to think about how do we choose an appropriate average. So again, we've got our 3 different types of average. We've got our mode, our mean, and our median. And all these are what we call as our averages of our data. And we need to choose the right one for the type of data we're dealing with. It's also important to remember that when you're dealing with statistics, there's a purpose and a motive behind choosing an average, and we must consider that as part of the equation. So consider our student whose marks out of, so a student has marks out of 20, in 10 tests. So the marks are 3, 4, 6, 7, 8, 11, 12, 13, 17 and 17. So let's look at what the mode, mean and median are. So the mode is 17. The mean is 9.8 and the median is 9.5. So mode is the value that occurs the most times, so there's 2 17s. The median, the mean is what you sum them all together and divide by 10, you get 9.8, and the median is the figure, the value that splits the data set in half. Now, if the student wants to impress their friends or parents, they're most likely to use the mode. But that is not a very accurate representation of how badly the student has done. And by using the mode, you could argue the student is being devious. So using either the mean or the median would be a better average for the student to choose. So some features of measures of central tendency are given in this table. We're going to do a table just to show the kind of advantages and disadvantages of different modes of different averages. So for the mode, to begin with, advantages. And we'll have disadvantages as well. So the advantages for mode is it's unlikely to be affected by extreme values. It's useful to manufacturers that need popular sizes or styles. If you remember back when we first started introducing averages, we gave the example of a shoe shop and they want to order shoes in different sizes. The most useful average for that shoe shop is going to be the mode, because they want to bring in the most shoes in the most popular size or style. And it can be used for all sets of qualitative data. The disadvantage is it ignores most values. So when we look at our student with these marks, the 10 marks out of 20, most of the values are ignored. It doesn't give an accurate representation at all, and it's rarely used in calculations. So now we're going to look at the mean. Takes into account all values. It's frequently used in calculations. And in fact, if you think, when most people talk about the average, they actually mean the mean, which is our next point. It's the most commonly understood average. And it can be used to find the sum of data values. Disadvantages is it cannot be found unless all values are known, and it's likely to be affected by extreme values. For example, when we think about if you were to find out if in your region you decided to calculate the mean income, if you had a few millionaires living in that area, that would, and the rest of the people were not wealthy at all, the mean would be affected by that because you've got these extreme values. It could skew your results to give an inaccurate representation of income in that area. So median can be found without knowing all the values. It's relatively unaffected by extreme values. So median would be a good way of talking about your average income in an area. Disadvantages, it only takes account of the order of the values, so ignores most of them. Now, let's look at another example. Let's consider the number of days a courier company delivers 100 packages. So we've got number of days, so we've got 1, 2, 3, 4, 5, 6. And number of packages. So it took them 1 day to deliver 10, 2 days to deliver 40, 3 days to deliver 25, 14, 8, and 3. So and we've got our days here, and we've got our frequency here. So we do 10, 20, 30, 40, and then we'll have 1, 2, 3, 4, 5, 6. So for 1 day, there was 10 packages. 2 days, 40 packages took 2 days. 25 packages took 3 days. 14 packages took 4 days, sorry. 8 packages took 5 days. And 3 packages took 3 days. So now we've got this, we've done this as a bar graph. Now we're going to get an overall shape. Now I'm going to put the shape in a different colour just to make it kind of stand out a bit more. So we start here and we just get kind of a general, we could have picked a better colour, it's not shown up very well, has it? Let's use this one. That's better. So what we can see by just looking at the shape of the graph is skewed. It's not. It's, if we think about, it doesn't go like that. It's kind of off center like that. And sometimes you can get data that would go the other way, like that as well. So we call this being skewed, and this is a nice kind of symmetrical. This is not symmetrical. So the mode, let's look at the three different types of average. So let's say the mode. The mode is 2 days. It's the most frequent, that's easy to see. The mode is 2 days. The median is between the 50th and 51st value, because there's 100, so it'd be 101 divided by 2. So that gives us the median, sorry, is 2.5 days. So that's quite close. It's kind of in here. So it's quite close to the mode. And then the mean is, well, there's 1 for 10 days. There's 2 for 40. 3 for 25 days. 4 for 14 days. 5 for 8 days. 6 for 3 days. That's a terrible 6. And we divide it all by 100, and that gives us 2.79 days. The mean is the largest of the averages, and that's because of the long tail on our data. The mode is the smallest average, and that's because we've got this short tail here. And the median is between the mode and the mean. The set of we've talked about the set of data is asymmetrical and it's skewed. With the curve's longer tail, it's tail to the side of the larger values of this bar graph. So we say this is positively skewed. So if this would be a symmetrical, this is positively skewed. And this would be negatively skewed. And in general, we can find out, we can look at the mode, mean, and median, and then be able to find out and be able to just know if the data would be positively or negatively skewed. So let's just draw our, again, this is kind of a representation of something that's positively skewed. And we would do that if the mode was less than the median is less than the mean. Now, if it was negatively skewed, so it would look like, so we'd have the long tail in and then something like that. So that's negatively skewed. We would have the mean is less than the median is less than the mode. So the opposite way around. So I hope that helps.